Our third presenter today is Péter Vidos, and Péter has been involved in digital product development in the last 15 years, a startup CEO and COO, mentor, freelancer, and executive. So please welcome on stage Péter Vidos. The title of his presentation is Towards the Grammar of Animation. So Péter, the stage is yours. We cannot hear you. So just a moment.
Yeah. Hey, everyone. Thank you for having me. You can hear me now, right?
Yes, now we can.
Okay, cool. So thanks again for having me. In the abstract that I provided, so first things first, I promised you the world's most popular TikTokers. So here they are, shown on this really nice racing bar chart. It's a very popular chart type, animated chart type, so much so that at a certain point they were banned from the subreddit Data is Beautiful. We can understand why they are so popular. So you can see the trends really well. I mean, it gives you tension. Okay, we speed the thing up a little bit to get to the end of it. And now we see that the world's most popular TikToker is Charli D'Amelio. Cool. Most importantly, so the same data can be plotted on a line chart. It's basically the same thing that you can see here. And then the difference is pretty obvious, even though here it shows the historical trends. In one picture, you have to be very determined to sort out which line belongs to whom. And whereas with the racing chart, it's basically you look at it and it creates a movie-like experience. So you just lay back and enjoy the show. There is tension in there. One player takes over the other. So it's a much more enjoyable thing to watch. And of course, there's plenty more space here for extra information. You have the photo of the TikToker and also the name next to the number. So it's a much better way and much easier to comprehend what we can see rather than with the line chart, even if I add some more information, but I can only squeeze in the top three's final result. There is one burning question other than who the world's most popular TikToker is or was, which is like, what am I doing here and why am I doing this presentation about the grammar of animation, or so a presentation about animated data viz. Actually, I could be any of these things, but I'm none. So I'm not a data scientist, I'm not a data visualization expert, nor a designer, but I spent the better half of the most of last year's building something that we just released into public beta, and that Elijah Meeks, the founder of the Data Visualization Society, just described as the most complete form of animating between chart forms that he has ever seen, for which we are very grateful for Elijah, actually. And this thing is called Visu. And as you can see, as it showcases some of these transformation that this video, what Visu can do, it is indeed a very flexible thing. So basically, the motivation for us to create this, right now it's an open source tool, an open source JavaScript library, by the way. So the motivation for us to build this was we feel that the UX of charts are fundamentally broken. I'm not going to get into more detail than this. Maybe that's for next year's talk. But in order to fix that, we knew that we definitely need animated charts and a generic engine that can generate and transform these charts from one into the other. So we created an engine inspired by the grammar of graphics. That is a set of rules describing static charts. And the engine is in a way that it provides a common interface for several different chart types. And then we made each parameter of the engine interpolatable. So basically we created a generic chart animation engine that can continuously interpolate between any chart type, any chart types that can be described on its interface. And then we started looking at these transformations and try to understand which are the ones that are easy to follow and that work well for a viewer, and which are the ones that just puzzle the user. And via doing so, we discovered a set of rules. This is basically these are rules of the grammar of animation, and we don't feel that this is a complete set that we already have. We're working towards to have the grammar of animation, and actually we would like to invite you and everybody interested to participate in this process of identifying the rules and being able to use an open source and free library like ours. We hope that this is the right tool to do so. So, but this presentation is about these rules. I mean, at least some of them that we identified. First, let's start very simple. Why do we need animated charts in the first place? So what they add to the experience of viewing and interpreting charts. Right now, what we're looking at, it's Donald Trump's tweets. So it's the number of tweets in each year. That's the height of the column. And you can see described by the color which tool he used, whether it was his iPhone, his Android phone, or the web interface to send his tweet. And I'm going to show you a couple of views of the same data set. And I'm just curious if you can guess what we're actually looking at. So what that chart is actually showing you. I'm not going to tell you that. Sadly, since this is not a live session, I cannot ask you to shout the solution at me, but you can shout at your screen if you want to. I would really appreciate that. Okay, so there'll be three different views. This one, guess what it might be, and this one, and then lastly, this one. So if any of you were capable of following along and knows what we're looking at right now, I mean, you deserve a pat on the back. That's something special, but I'm pretty sure you had to focus really hard, even those of you who could follow along. And that's because we are just not equipped to, so it takes a lot of energy from us to constantly reinterpret what we're looking at and trying to figure out what the connection with the previous view might have been. But if I switch on the animation between these states and do the same, like just let it for you to interpret what we're looking at. So now I'm pretty sure it has been much clearer for you, and that is like a good example of the power of animation and what it brings. If we take a look back and try to or take a step back and try to understand why is it so and what is needed here. So basically, currently there is a need for better comprehension with less effort, because obviously the abundance of data is huge and there is an attention deficit from the people's side. So any solution that would reduce complexity while increase the comprehension and decrease the effort needed is something that that would be met with good reception. So from the perception point of view, it's a genetic, so it's a very humane condition to be capable of tracking movement better than tracking static things. If an already familiar item changes, then that's very interesting for us and we pay attention. And we actually perceive movement with different parts of the visual cortex, which we don't even use when we look at static charts. This has to do with, like, we have to see if something attacking us, and so it's a very deeply natural thing, and it automatically activates when we see something moving, and the trackability. So this is a huge advantage of the animation, that we don't need to look for the same items in a new setting. We just naturally connect the two. and there's no need to make this connection, this abstraction in your head. In terms of methodology, what animation brings, so on one hand, it simplifies things. I'm going to show you examples to all three. On the other side, it extends the opportunities and of the people who use data visualization, and also it gives you the opportunity to phase things, which is a great tool for better comprehension. In terms of use cases, we feel that storytelling is an obviously strong application of the animated charts, and also exploring different views of the same data while never losing train of thought due to the animation is also something very important, either for analytics professionals or for the general public. And actually, with the use of Visu, there are opportunities to combine these two, so storytelling and exploration, and that's what we're hoping to achieve later on. An example for simplification, for the extension, and for the phasing. The simplification, it's basically the racing bar chart is just a perfect example. I already said that what is going on here. Basically, the animation adds time as an extra scale to data visualization that you can put data on. So this is what you can see here. This is why it can be so simple, because the data, the time data is put on the animation scale. And yeah, the racing part, I already said the upsides of that. So if you look at another example, so I'm sure all of you are familiar with the work of Mr. Hans Rosling.
It was only this part of the world that was getting richer and eventually healthier and healthier.
Dubs or comments on his charts. So as you can see, he's using here a bubble plot that is moving as we're progressing in time. And the fact is that on his charts, he's using all the available options, even without the movement. So there are two measures on the X and the Y axis: life expectancy and income per person. There's categorical information on the colors of the bubbles, which is to which continent they belong. The bubbles itself represent countries, and then the size of the bubbles tells you how big the population is in these countries, and that's that. So basically, there is no way you could put an extra continuous or discrete value on this chart without making it utterly and unreadably complex. And this is, so he's using the animation or the time scale very naturally, just by putting the years over there and then animating between the phases. And this way, you know, he extended the possibilities of data visualizations by using this solution. And the third opportunity is to phase the animation, which is good because so, for example, this previous chart that Mr. Rosling used was pretty complex, bubble plot, but you can actually use animation to construct such a chart and make it easier for the viewer to understand what they're looking at, even just a static part of it. So like one slide of Mr. Rosling's presentation, by using the animation and adding the different data series one by one to your chart. So basically now we look at the population of continents, and then we can split these up and drill down and see the population of countries. Now we're gonna distribute them along the x-axis and then put the average number of child per woman on the y-axis. And as an additional measure, we add the average income per person on the x-axis. So we arrived to a similar bubble plot to what Mr. Rosling had, but doing it step by step makes it easier for the viewer to comprehend the context and the information on the chart. So finally, about the grammar of animation that we're working towards with Visu. So it all, as I said, it originates in the grammar of graphics. It's actually the original grammar of graphics framework was proposed by Leland Wilkinson that covers all major aspects pertaining to effective data visualization. And then a variant of this known as the layered grammar of graphics, to which this is an illustration that you're looking at right now, was proposed by Hadley Wickham, a very well-reputed data scientist and the creator of the famous R visualization package ggplot2. But actually Plotly and HoloViz, which are tools you might be familiar with, are also basically implementations of the grammar of graphics. And it also provides sort of like a logic of how you should visualize data for it to make sense for the viewers. And we realized early enough that in order to, and that's going to be the first rule that I'm going to illustrate to you, is that we have to keep the rules of the grammar of graphics in order to make sense with the animated charts. So I'm going to show you two examples. First, with the Visu like beta in an HTML page. So the first one is that there you can only stop your animation and call it a state when it actually abides the rules of the grammar of graphics. So let's see, here's a stacked column chart, and I'm going to start the animation and just aggregate or get together the rectangles of the same color and get to this state. So this obviously is not something that that works really well. An additional step is needed because we have rectangles of the same color on top of each other. There are basically plenty of, at least two things that I can do here. Either I change the lightness of these rectangles to make them different from one another, or I can aggregate these. So if I just going to reload the page and show you the second phase, we chose the letter. So we aggregate the elements and then the final result actually fits the grammar of graphics. And this is something you can use in the animated world as well. The other general rule that we discovered is that it's actually, I think, the most interesting one. So what you expect from a chart is that it well represents the data that is shown on it, like accurately. And what you expect from an animated chart is that you can trace the elements when they move from one state to the other. These are obviously very important rules, but there can be occasions when these get into some conflict. Like, for example, here we switch the orientation. So we just gather the elements along the y-axis. Yes, once again, this is an interim state. We should obviously aggregate once again the elements, but that's not what I'm going to point out right now. So basically, everybody understands what's going on, even though there are moments within the animation when the representativity of the chart is totally broken. So you see these rectangles all have the same size, even though obviously they should be different size. But since it's just, it happens mid animation, we don't feel it's so unnatural. We don't really have a problem with it. So let me just reload the page and show it to you in real time. I don't think anybody has any issues with that snapshot when the chart actually doesn't represent the data very well. And then finally we aggregated the elements, as you can see. Okay, so moving back to more specific rules. I'm going to show you 3 of those, and then I think we can open up for questions. So showing and hiding different elements. It's important that when you do so, so let's say when you hide elements, you first want them to fade out, and then you let the remaining elements take their place, like here on this tree map. It's important that you do things in this order, And the other way around is that when something appears, so when we phase them back, then first the elements that are already on the chart, they should get to their new positions and leave space for the appearing elements, and then they appear. So let me show you how, when it's done in the wrong way. As you can see, it's so much harder to follow, and it's pretty problematic how it's being done in the second example. Yeah, I mean, in Visu you can you can make things the wrong way, but it takes some effort. But it's possible, as you can see. These are all these examples were all created by that. So actually, this rule of how to show and hide elements, it applies to all different chart types, regardless of the geometric element used, or we've seen charts with Euclidean coordinates, whereas this is a bubble chart that is without coordinates, and they are all, and this is a line chart, which we haven't seen before, and they are all the same in this regard. So this is a rule that we feel that it meets. So it has to be kept in under any circumstances, even if you just filter certain elements or hide certain elements of a stacked chart. It doesn't matter. It's always the same. And on a bubble plot as well. So as you can see, first they hide, and then the scales, the range of the scales applies to this new situation. But the rules in the background are the same. Okay, another example, also very so something that happens all the time when you're using charts, especially using animated charts, is that you add or remove a dimension, meaning adding or removing categorical data series. So when you do that, it should first appear, so it should first separate the markers where they are, and then the markers can move to their new position. It means that the new markers, so for example, in this case, we have 4 markers, the 4 columns, and then now we have 12, and they basically appear in the place of the 4 other markers. So they just cover them in a sense, or split them up, and then they can move to their new position. And it's really, really important. This can also be done in the wrong way, and it means that there's no system that can animate if you mess with this rule, and then yeah, it's even worse than when I was just showing you static charts, I think, because too many things happen at the same time. And then this is really important actually with animated charts, that you have to limit how many things you change in one animation phase to make it easy for people to follow along. So adding and removing dimensions the right way, it applies to a lot of different chart types. Here we add the new dimension on the y-axis and then split up the markers along the axis, but they have to appear in the same place as their aggregated form. And the same with the bubble plot as well. Sorry, a bubble chart. As you can see, the big circles split up to smaller ones, and then they move to their new position. And again, when we aggregate, they first move to their final position, and then we can aggregate. Okay, third and final specific rule is about moving rectangular elements. So obviously there are different geometries we can use, and we found that actually rectangular, so charts made of rectangular elements like bar and column charts are special, especially in the when they have geometries. It's like when we have to move them around, it's much better if we can avoid them overlapping with each other. When they overlap, people can lose their train of thought. They can this whole easy comprehension and movie-like experience breaks, and you don't know what went where. And so this is basically the way you want. I mean, you've already seen this animation plenty of times, and as you can see, these elements, they are all moving along the axis in separate phases. So first they move basically horizontally, and then vertically, and then the other way around. when you and they do it in a way that they don't overlap with each other. In a wrong example, yeah, this should say the wrong way. In the wrong example, they overlap with each other, and that makes it impossible to follow along. Some good examples here. So whenever you can do this when you're grouping elements, and you can see there's a certain order which this should happen, unlike in the bad example, so that they don't overlap. And when you're using polar coordinates, it's basically they also abide the coordinate system, meaning that they move along the polar coordinates right now, the same way they do with the Euclidean coordinates. And no matter what kind of transformation you do with them, so with the rectangular elements, they always have to follow this simple rule to abide the coordinate system and try not to overlap with each other. Yeah, like this. Okay, so there are actually other rules that we already have identified. We are working always to be able to properly formulate them. We think that by using our open source library, it would be great to involve others to the experimentation of how to really have a fixed and complete grammar. And I invite you to join in. So basically, we actually implemented the rules we already know of in our own library that you can find on GitHub and at this website. You can find the link also for our Slack community, for which we invite you very warm-heartedly, because if you want to join in the conversation, if you just want to test how you can build animated charts with Visu, go over to GitHub. If you want to talk about it and getting involved in the grammar of animation, then come and join our Slack channel. If you want to follow along our story, just follow us on Twitter. And if you have any other ideas on where you want to implement this thing or what you could use it for, I'll be here in the networking part of the conference, but also just write me a couple of lines and I'll be happy to answer. So yeah, thank you very much for your attention, and I'd be happy to take some questions.
Thank you very much, Péter. This was really amazing what you can achieve with these graphs, and I really liked it.
Thank you.
And we have some questions. And for the audience, I would like to encourage you to you can put questions in the stage tab of the Q&A part, and also don't forget to vote in the poll for the presentation. And now let's see what question we have. So the first one is from another Péter. Thank you for the presentation. I am interested, how can it be used for teaching topics like informatics or mathematics? For example, could I plot a complex function or a 3D mesh grid easily?
A 3D mesh grid, was that it? So, sorry, did I hear you right?
Could I plot a complex function or a 3D mesh grid easily?
I'm not sure about the last part, but you can definitely plot a function. So basically, if you go to this website and that I mentioned to you, and you can check out the tutorial here. It's as you can see, it uses a pretty straightforward code structure. So you can just set things on the channels when you already have it, and then you just basically rearrange it and put the different series to another channel, and then the system will automatically animate them. With the mesh part, my CDO just texted me that it's not yet possible, but there are plenty of other things that you can do with this. So for example, switching from value view to percentage view is just one parameter. so it's pretty easy to use. And we would love to have it used in teaching. And if you have any sort of ideas in how you would want to do that, just let us know, because we are here to learn. I mean, this is the part that I mostly enjoy, having an open source libraries that people come and approach us with their ideas, and we're very open to all of these.
Yeah, thank you. The next question is the Canvas renderer performance adequate with large number of objects? Is WebGL considered as an alternative?
Well, so yes, we don't have issues with performance. We have examples where we actually use thousands of markers, so thousands of elements, and we didn't have any issue with the performance. And it's actually the reason for that is that it's written in C++ and compiled to WebAssembly, and it works really well. Then again, maybe I'm not the person with the best insight performance-wise, not being a technical person myself. As I said, I'm none of those listed, not even a technical person. But I know that we don't have performance issues in this regard. So
yeah, we still have some questions. That what was the most popular or most complex thing what you put together with this?
We built basically stories and interactive explorers ourselves before. Our most popular story on YouTube was a video we created about the people in Chernobyl who had to clear the radioactive debris out of the roofs, so the liquidators, how much radiation dose they got. We plotted that in real time, and that got very popular, and we compared it to certain other elements. But we also published our stories on Reddit, where some of them got to the front page and got a couple of tens of thousands of upvotes. You can check those out if you look for VisuHQ on Reddit. And we built, for example, an interactive explorer that was showing the actual information about the coronavirus pandemic here in Hungary, and it was the crown jewel of the most popular independent site from Átlátszó that was very under hyper traffic like a year ago, when more like a year and a half, when people really wanted to know what was going on, and you could make and prepare certain views for yourself, so you could compare the how the pandemic was spreading and how many tests were made and how many of them were positive, and you could just explore the data with simple tabs and buttons with that.
Mm-hmm. Thanks, that sounds great. Another question is how difficult is to use or to work with the Visu?
I mean, making it as simple as possible was our key one of our key targets. As shown in this tutorial that you can yourself reach very easily, just at lib.visuhq.com and clicking at the tutorial and examples, you can see that I mean, first there's an intro part talking about the data and stuff and how you can add data. But as you can see, it's like putting really just phases of the animation one after the other, and then Visu will automatically animate between these phases. So it's like very easy to use, and with the help of this tutorial, it would be super easy to learn how to use it. Actually, we're gonna have workshops in real life and also in in online. So if you follow us, we would be happy to, get you involved and walk you through the starting to use Visu in some practical examples, and like just this Saturday, we're going to have at MOME, local university. So if you're around Budapest, feel free to join, and we can teach you how easy it is to. So for example, this is again the example when it's done the bad way, this whole animation, and then the good way. And as you can see, it's like 5 lines of code.